Hello, can you hear me?
Yes, uncle. Now I can.
So, how was the exam?
Yes, uncle. It was. I did good.
Very well, good. Okay, so you double checked every step and everything, and hope to get centum.
Yes, uncle. I did well.
Good, good. Okay, so last week we were looking into the series, and you replied that you understood. I mean, you see the writing. I gave the explanation, and everything is okay with that.
Yes, uncle. Yes, uncle.
Yeah. So the main thing is we have to give the full consideration of what is available and given to us, and we can build upon that. There is no problem with we need to know lot of things and everything about a problem in advance. There is no need for that actually. So we should be ready to think about, okay, this is the given information and we need to give full importance for. There is nothing called this is a small information and this is an important information. Not like that. It has to
Yes.
be, everything has to be considered in the given information, and we fit all of them into a, yeah, we have to visualize that, and after that the things needed to deduce the steps and the procedures will follow it up. They said okay.
Yes, uncle.
Okay, so all the exam, the final annual exam.
Uncle, tomorrow is chemistry.
Oh, okay. Chemistry is there. Okay.
Yeah.
Okay. So, do you have anything in particular? Even chemistry, you want? I mean, I'm not that good at chemistry, but I have some knowledge about chemistry. Uh,
Okay.
do you have any particular concept or something in chemistry to
Uh,
go about?
yes, uncle. Actually,
Hmm.
uh, resonance. I didn't clearly understand that.
Resonance, which comes under what topic?
1 second.
Yeah. If you even
Mm.
take a snapshot or something and
Yeah,
send.
yeah. Yes, uncle. Yes, uncle.
Yeah.
It's not exactly a question. It's
Yeah,
just
the concept
yeah.
of, yeah. Because resonance is a very generic word.
Yeah. Okay.
Okay. And a lot of things, mean the resonance can come from anywhere. So we need to look into what kind of resonance under what topic in the chemistry they are talking about. Then we can
Yes.
do that.
Yes, uncle. I have sent it.
Yeah, yeah. So it's downloading. Okay. Okay. So the ionic charges and everything attached with the, I mean, because of the lone pair electrons available with oxygen or nitrogen, you are okay with that? Those things, because they are all going to be further
Yes, uncle.
when they make the molecular bonding, the electronic or covalent or the mm, coordinate bonding and everything, uh, the the size of the atom and also the lone pair electrons will make the whole structure of the the whole molecular structure. Okay. So
Yes, uncle.
first to get this downloaded. Okay, 1 second. Uh, Just save that and then open it. Let me. Okay, let me share this in our Zoom. Let me stop this.
Okay.
You can see that, right?
Yes, uncle.
Okay. Let's start looking into this. Okay. So they call, okay, first of all, the word resonance means the literal meaning itself is something like something going along or something resonating, like so it comes from, okay, there could be something opposing or something could be more going along with that. Do you see that?
Okay.
So
Yes,
that
uncle.
is the kind of thing the word resonance is. So something can be accumulated over the period, like because of that, some in addition to that, it will get enhanced. That's the whole idea of the resonance. Okay.
Yes, uncle.
So here the resonant effect is defined as the polarity produced in the molecule by the interaction of two pi bonds or between a pi bond and a lone pair of electrons present in an adjacent atom. So up to here it is okay.
Yes, uncle.
Okay, so the polarity, you know that there is a positive and negative polarity.
Yes.
So that is actually the polarity produced in the molecule. So the molecule will have a polarity. So with respect to the structure, so it is not symmetric. So towards the one side, it will be more, looks like more positive charge, and other side looks more negative charge. So even though it is a completely a neutral molecule because of the bonding and things like that, but there is a bit separation of the charges. Do you see that? That is what we
Yes,
call
uncle.
polarity produced in the molecule by the interaction of the. So this particular polarity, which is produced by the interaction of the two pi bonds or between a pi bond and a lone pair of electrons present in an adjacent atom. Okay. The effect is transmitted through the chain. So there is a possibility like there may be some compounds are like it has a long chain. Okay, it may
Yeah.
keep connected with the long chain. So the resonance that is, I mean, started at one point, it can propagate and it can go to the other end, and from the other end, it will get propagated back. And then when the length of the chain is actually good enough for the speed at which this propagation is, then there will be a resonance. So think like, let's say there is a string fixed at two ends. Okay.
Yes, uncle.
Like our guitar string is actually fixed at two ends, right?
Yeah.
And what we do, we try to make a stroke with a finger or whatever that small thing we have, the device.
Yeah.
And then we make a small vibration, and that vibration will propagate.
Yeah.
You can feel it, right?
Yes,
So
yes.
that
Yes, uncle.
vibration, we will be giving a stroke and it will vibrate and it will hit both the ends and it will get reflected.
Yes.
So the one which is propagating and the one getting reflected, they will make a resonance and they will form a standing wave pattern. Actually, physically, they will form a standing wave pattern.
Yes, uncle.
So you can you see that it can be a one in physics you have studied this, right? Standing wave
Yes,
pattern.
yes,
Yeah.
yes.
And that the wavelength of the standing wave pattern will decide what is the wavelength of the sound which will be produced by that particular guitar string.
Yes, uncle.
Okay. So now here let's see further with that. The effect is transmitted through the chain. There are two types of resonance or mesomeric effect designed as R RM effect. Okay, they have some terminology here. Okay, so let's
Yeah.
look for what is a resonance and then what is the mesomeric effect. So first one, positive resonance effect plus R effect. In this effect, the transfer of electrons is away from an atom or subsequent group attached to the conjugated system. This electron displacement makes certain positions in the molecule of high electron density. This effect is outlined in in aniline. Okay, this effect is aniline is shown as. Okay, so what is happening? You have the ammonia molecule, not the molecule, the
Yes.
radical
Yes.
attached with a benzene. Do you see that?
Yes.
So one NH3 is the ammonia, and but one nitrogen
Radical.
is not there, then it become a radical, and that is attached with the carbon in the benzene ring. Okay, and
Yes.
with the nitrogen there are 2 electron, and that is going to get moved to the bond. Do you see that? That is the first picture.
Yeah. Yes, uncle.
Okay. And then when the electron is moved, then we say that it has already a positive charge there. Nitrogen it lost 1 electron. Do you see that?
Yes, uncle.
And then so that is actually going to further down.
Yeah.
That is the next picture they are trying to say that.
Yes, uncle.
So then what is happening? So you see now when it is propagating, the bonding is changed. Do you see that?
Yeah.
So the double bond inside the benzene, that is moved to form a bond with the
Yes.
nitrogen, that radical NH2, and then because of that there is become a single bond that automatically makes that there is a 2 electrons, that is an excess electron will make it as a negative charge in that corner.
Yes, uncle.
So look at the carbon. Okay, the carbon which has a 2 double bond attached with the nitrogen. Okay, that is exactly all balanced because there is a 2 bond with the nitrogen and 1 bond going to the other carbon on the left side and another carbon on the right side bonding. Do you see that?
Yes, uncle.
So the one in the top corner of the benzene ring, that carbon is completely balanced with 4 bonds.
Yes,
But
uncle.
the left side carbon, now the double bond is missed. So it has only 2 bonding, and then there is a 1 bond with the hydrogen. So that means it is less with one bond. Do you get that?
Yeah. Yes, uncle.
That is the reason we say that looks like, at that moment, it looks like it is negatively charged.
Yeah.
But this won't stay there. It is like just a vibration on a string. It will get propagate. So it will be moving to the next one because there is an imbalance. Do you see that? It cannot be like this. So it will propagate, and the propagation will make the next stage. Next stage, you see that the bonding, now the double bond here move to there. So slowly you see that the double bond within the benzene moved to the nitrogen radical, and the forward propagating of that electron makes the double bonding missed one after the other corner. Do you see that?
Yes, uncle.
So for going from left to the right, this is happening, and every transition, it is not only one way. So it may, the nitrogen bonding, that electron can move and it can go back also. That is why the arrow mark between the two molecular structure, they put it both left and right. You see that? So it can go either way. So now do you get the idea overall?
Yes, uncle. Yes, uncle.
Okay, so this is what is called the positive resonance effect. And at the very end, you see the charge, the electron started propagating through the benzene ring, and eventually it looks like the charges are bit separated. There is a positive nitrogen radical, NH2 radical there, and that particular carbon on the right side of the benzene ring has a extra 1 electron. So that is what it looks like. Is it okay?
Yes.
Okay, so now there is another one called negative resonance effect, minus R effect. This effect is observed when the transfer of electrons is towards the atom or substituent group attached to the conjugated system. For example, in nitrobenzene, this electron displacement can be depicted as. So now let's see what is happening. So now, in the previous case, the positive resonance effect, plus R effect, from the NH2 radical, the electron went into the benzene. But this time around, I mean, the diagram shows that from the benzene ring, the
Benzene ring, it
electron
goes.
is getting into the NO2. So that is the reason that, okay, N has that the double bond O, and there is another O, and we have a. So what is the difference for that single bond arrow? It is a pi bond, or you see the nitrogen has
Yeah.
there is
Yes.
arrow mark with that. What is the meaning of that arrow?
I think it's supposed to be a single bond only. It's
So single bond, but the arrow, I have no idea why they put a arrow there.
no, because I think they're representing the bond only, because because this single bond is from the benzene ring, the double bond is going to the place where N is bonded with benzene, right? And then from there it's going to oxygen.
No, there is something happening here. Maybe we are talking about the oxygen in the next nitrobenzene, because you see that nitrogen, which has already one bond with the benzene, and the oxygen takes the double bond with the nitrogen. So N is valency 3. It already have 3 bonds. Do you see that?
Yeah.
So also nitrobenzene is actually C6H5 NO.
Okay, yeah.
You cannot have NO2.
Okay.
So this looks like the other arrow mark and that other oxygen. It's maybe because nitrobenzene, I think, is a liquid state compound.
Okay.
So that will be having the neighbor a molecule of nitrobenzene.
Okay.
We are seeing the other one. Let's see how it goes. Okay.
Okay.
So the first, this one is electron is moving to form the double bond with the nitrogen. Because of that, it become a positive ion in the benzene. And once that is gone there, and they start drawing that is actually made an extra negative sign with the oxygen. Do you see that?
Yeah. Okay.
Okay. And then they are going to have the propagation in the benzene ring. The propagation is, it is propagating as a positive charge. Do you see that?
Yeah. Yes.
In the previous case, it was a propagation of the negative. It is, so when the negative charge propagate and the positive is fixed, we call that as a positive R effect.
Yeah.
And the negative R effect is the propagation is for the positive charge, and the negative charge is fixed. That is
yes.
And why they want to show the other oxygen there, that I don't know. It is not at all. Maybe the presence of a bit of an energy coming from there is helping this process. Because you see, there has to be a reason behind something like this is happening. Do you get that? Something has to explain that. But in this case, they are not showing anything like that. Simply the lone pair electron itself can do this job. Okay. But in this case, it looks like it may be in-depth understanding. The real dynamics is maybe because of the another double bond oxygen coming from the neighborhood nitrobenzene that is actually initiating this process, or maybe no idea.
Okay.
Is that okay? But the main understanding is the propagation is for the positive charge, and then the fixed charge is the negative. Then this one is called the negative R effect. Okay.
Yes, sir.
So the atoms are subsequent groups which represent plus R or minus R electron displacement effects are as follows. So plus R effect is negative halogen. That is, it could be a negative OH, or it could be a negative OR, or it could be a negative OCO. So this is a process. So it starts with the nitrogen, halogen, and then it propagates to the OH, and then OR, and then OCOR, and minus N2H, and then minus NHR, minus NHR2, and minus NHCOR. Okay. So how many of them we have? 1, 2, 3, 4, 5, 6, 7, 8.
Yeah.
So look at this picture. So the first 1, 2, 3, 4, 5, 6, 8. Do you see that arrow? So the very
Yes.
first molecule, the nitrogen from the electron from the nitrogen coming to the bond, that is a one action. You get that? That is the
Yes.
hyphen halogen. And then the next one is in the same molecule, that carbon, that is actually transferring the charge to the next corner carbon. So there is two
Yes.
of them. So the first two things is our negative halogen, negative OH. That is what it is.
Okay.
Okay.
Uncle, aren't those just examples?
I think so. I think so.
Yeah.
Because it is not talking about, yeah, it can happen with the molecules which
With
has
these
this kind of,
examples.
either it should have a halogen or it should have a alcohol or O radical kind of bonding or OCOR or
NH2.
NH2 or NHR, all this kind of molecule structure
Yeah.
will have a plus R effect, and minus R effect is possible with organic acid or aldehyde or ketone
Ketone.
or cyanide
Cyanide.
and
NO.
this nitrogen dioxide. They put a hyphen NO2 here.
Yeah.
Here, NH. Because nitrogen is 3 valency, right? So that is why
Yeah.
ammonia will be NH3. So now in this, the one covalent bond attached with the carbon, that is one bond, and the 2 hydrogen next to the nitrogen will make the 3 bonds. And that is why I was questioning that, okay, the other oxygen, I don't know where it comes from. But in the example of the minus R effect, the very last one, they put it as a minus NO2. What is that?
I think that is nitrogen dioxide. That's what they have. That is the example they have used in minus R effect.
I could see that, but that is imbalance, right? Nitrogen, how come you have 4 of them? So this arrow mark looks like a coordinate bond, actually.
Okay.
You studied the coordinate bonding.
No,
because there are different kind of bonding, right? One is electronic bonding, one is covalent, and then the third type is a coordinate. Okay, so it looks like there is a coordinate bond. I'm also not very clear with that, but
Okay.
Overall, do you get the idea? What is
yes, uncle.
You are better than before.
Yes, uncle.
Going on. Okay. Do you have anything else further on this to discuss about?
No.
Okay. Anything else from chemistry?
Yes, uncle. I'm the same.
Yeah.
Yeah, uncle. I think that's it. So,
You're okay with that? Okay.
yeah.
Okay, I mean, any subject, any topic or something like that, we should be ready to keep an open mind. Like further with what is explained, can we go and look in all possible ways what is going on and try to make sense out of that? And we need to don't just escape. Something looks okay, I escape. Like we need to keep questioning until we have a clear idea about what is going on. Okay, that will make
Yes,
us more the thought process, the way we think and everything, it will give more confidence, and we will be ready to look into everything in detail and very careful, and we won't do mistakes, and our understanding will also go only in the progressive way. Okay.
Yes, sir.
Okay, let me where is our meeting link? I will stop sharing this. Yeah, whiteboard should be okay. So do you have anything else, something from maths or something or physics to talk about, or you want to take the time to study chemistry for tomorrow's test?
Uncle, oh wait, 1 second. I'll just check it. In redox reactions, I just have one. Like oxidation and reduction, they're saying that oxidation is loss of electrons.
Yeah.
But why is that?
So, okay, it is getting oxidized, right?
Yes, uncle.
Yeah. So, do you have the picture of that page where they are explaining that?
1 second.
Yeah.
They've not given it exactly. Oh, they have not specified. Yeah, it's here.
Okay, let me check.
Yes, uncle, it's there. It's there. I found it.
Yeah, okay. It's downloading. So reduction and oxidation, those kind of reaction in short form, they call as redox.
Yeah.
Yeah, the RED is for reduction and OX is for oxidation. It's still downloading. My desktop is always slow.
Okay.
I could see this image in my phone. Oh, okay, now it is.
Okay.
This. Okay, let me share this. Can you see this?
Yes, uncle.
Okay. So the redox reactions in terms of electron transfer reactions. We have already learned that the reactions NaCl and they put S, G and S. What is the meaning of the S next to the sodium?
Solid, I think. Solid and G is gas.
Oh, okay, it's gas. Okay. So we have the sodium, two sodium, add with the 2 chlorine, you get a 2 NaCl. And the sodium with the oxygen will give you the sodium, is called sodium dioxide, right?
Yes, sir.
Yeah, sodium oxide, yeah. And then the last one is sodium sulfide.
Yes.
Or redox reactions, because in each of these reactions, sodium is oxidized due to the addition of either oxygen or more electronegative element to sodium. Okay. So basically, when you see the periodic table also arranged in such a way, there are elements, naturally, they are either having a property of attracting an electron or happy to give away an electron. Okay, so the natural property of the atom itself, the element itself is like that.
Okay.
Okay, so that is why the periodic table, I don't remember. If you go from left to right, you will see that it is more electron affinity to the one which is ready to give away on the other side.
Yes, yeah.
Like that. So that is a natural property. So like that, when they make the compound formed and things like that, like even the sodium chloride, one is a solid and one is a gas, and they are ready to make a combination like a sodium chloride, NaCl, the common salt, most of the common salt molecules are all NaCl compound, right? Solid state. Solid state, they don't have the entropy or the energy to really get the sodium ion and the chlorine ion to get dissociated. You get that? But if you give a water, if you add the salt, NaCl, to a water already has water itself, because of this redox reaction, the water can be, it's a kind of redox reaction. Water won't be available as a H2O. The room temperature itself that gives the energy for the H2O to be dissociated as H plus and OH minus.
Yes.
Okay, so because of that, there is when the salt is added to the water, the NaCl will also get dissociated as a Na plus and Cl minus. So what is the nature here? Easily it says that the sodium is a kind of element which is happy to give an electron, and the chlorine is an atom which is more happy to have one extra electron. Okay.
Okay.
So with this, we are saying that all these reactions are redox reactions, because in each of these reactions, sodium is oxidized due to the addition of either oxygen. So straight away, addition of the oxygen itself is called a oxidization, or more electronegative element to sodium. Okay, so in the case 3 example, the one in the middle, sodium with oxygen, is directly an oxygen is added. Otherwise, the first and the last are sulfur and the chlorine. They are more electronegative elements, electropositive elements.
Yes.
Okay. So when they are electropositive elements, so from our knowledge of chemical bonding, we also know that sodium chloride, sodium oxide, sodium sulfide are ionic compounds. Okay. And perhaps better written as Na plus Cl minus, Na plus 2O2 minus, and Na plus 2, the sulfur 2 minus.
Yes.
So obviously, it itself straight away, it shows that how many electrons are exchanged between the one atom of sodium to the one atom of the chlorine. Or in the case of the sodium oxide, obviously it looks like each atom is giving one electron. So there are 2 electrons from the sodium went to the oxygen.
Yes, sir.
Okay, so that is how we have to look into that positive and negative on the top right corner written on this molecular formula. Okay. Development of charges on the species produced suggests us to rewrite the reaction in the following manner. So we say that, okay, in the beginning we wrote like without the ions specifically represented, 2Na plus Cl2 gives you 2NaCl. But actually what is happening, 2Na plus Cl2 is actually each of the sodium is going to lose one electron, because it is a type of the element happy to give away the electron, and the chlorine, chlorine itself, it needs 2 atoms to form a Cl2 as a molecule, and that will be taken by both the electrons will be taken by the Cl2. So that's why in the end, we don't simply write it as a 2NaCl. It is more like a 2Na plus and Cl minus.
Okay.
So here also there is a bit of an imbalance. So the molecule itself is having the charges are bit separated. So there is an asymmetry. Do you see that?
Yes, uncle.
Okay, so that is the same thing for the rest of the other two reaction, like
Okay.
2Na and plus O2. Each sodium is ready to give 1 electron. So there are 2 sodium. So 2 electrons are lost, and those 2 electrons are taken by the oxygen to gain it. So in reality, we don't write simply a Na2O. We write it as a Na plus 2 and O2 minus. Okay, so the final thing is Na plus 2, sulfur 2 minus. Okay,
Yes,
so even though each of the sodium atom happy to give 1 electron, in the first reaction we have 2 sodium atom. That's why 2 electrons go into the chlorine molecule. In the second case, each of the okay. Okay. The second case, each of the, this is bit, this is not, they should have written in a better way. This is a better way to write that reaction. You see, you need four sodium.
yeah.
With oxygen 2, that will
Yeah.
give you 2 Na2O. And
Yeah.
this one should be written like that. I don't know why they did not do that. In the middle, it has to be like, it should be 4 sodium.
Yeah.
Plus, we need to say that oxygen 2. Then we have to say that 4 sodium will lose 4 electrons, and the oxygen O2 will gain that 4 electrons, and this whole right hand side, currently whatever it is written in the front of the sodium before the bracket, there should be a 2 appearing there.
Yes, sir.
I'm saying it should be same like the 4.
The second one.
Yeah, 4 is wrongly written as a 2, and
Yeah.
the 2 is on the right hand side, 2 is completely missed.
Yes,
Maybe they want to maintain that there are only 2 electrons going from sodium to, but that is not the case with sodium oxide, right?
Yes. Yeah.
They can easily say that there is 4 sodium and 4 electrons are lost, and 4 are gained by the oxygen. Right?
Yes, sir.
This oxygen will gain 2 electrons, and if it is a 2 NaO2, mean 2 Na2O2, then there are 4 sodium and 2 oxygen. So
Yes,
each oxygen will gain 2 electrons. So totally 4 is lost by the electron is lost by the sodium, and 4 is taken by
gained by the oxygen.
Yeah, 2 oxygen.
Yeah.
Each is taking 2. That should be the better way of understanding. Okay, but actually, they want to keep it as the Cl2, O2, and S, and they want to just say it like that. But anyhow, but you got it right. What?
Yes, uncle. Yes. Yeah.
For convenience, each of the above process can be considered as 2 separate steps. One involving the loss of electrons and the other the gain of electrons. As an illustration, we may further elaborate or expand actually. One of these, say, the formation of the sodium chloride. So when we say that, first of all, 2 sodium dissociate into 2 sodium ions, positive ions, and plus 2 electrons. And that 2 electrons given away by the 2 sodium atom, they go and attach with the chlorine molecule to form a 2Cl minus. That makes more sense, right? Did you get that?
Yes, sir.
It's a single go. So each of the above step is called a off reaction, which is explicitly shows involvement of electrons. Some of the off reactions gives the overall reaction. So that is what is written here.
Yeah.
So this whole thing is explaining how the molecule, new compound is formed, and how the electron move around by the natural property of the element involved, whether they are more having the electron affinity or ready to give away the electrons. Okay. So
Yes, sir.
reductions 8.12 and 8.14 suggest that off reactions that involve loss of electrons are called oxidation reactions. Similarly, the off reaction that involve gain of electrons are called reduction reactions.
Okay.
Okay,
Yes,
but
sir.
yeah, but okay, they put the reaction number 8.12 and 8.14, but 8.12 and 8.14 are not written as two off reactions. Do you get that?
Yeah.
When you see the 8.12 in the form of off reactions, like what is written on this page, at the right hand side of the page column, 2Na dissociate as a 2Na plus 2 electrons. That is what is called as the electron, that is oxidation, right?
Yes, uncle. Yeah, that is oxidation.
Yeah. So because losses of electrons are called oxidation. And then those two electrons given out by the sodium attached with the chlorine, we call that the second off reaction as the reduction.
Okay.
Okay, so oxidation is losing electrons, reduction is getting added with the electrons.
Yes.
Okay, the gain of electrons. It may not be out of context to mention here that the new way of defining oxidation and reduction has been achieved only by establishing a correlation between the behavior of the species as per the classical idea and their interplay in electron transfer. Electron transfer, it should be exchange, right? Why they call electron transfer change, I don't know. Okay. In reactions 8.12 to 8.14, yeah, all the three, which is oxidized, acts as a reducing agent. Okay, so when it get oxidized, they are called reducing agent.
Yes.
Yeah, because they are getting reduced by the number of electrons. So sodium is the reducing agent. You get that?
Yes, sir.
Sodium get oxidized, but it is a reducing agent because it donates electrons to each of the elements interacting with it, and thus helps in reducing them.
Yes, uncle.
So the chlorine is getting reduced, but that process is possible. Reduction of chlorine or the oxygen or the sulfur is possible because of the reducing agent, which is ready to give the electron, donate the electron. So when the reducing agent donates the electron, what they go through is called the oxidation.
Yes, uncle.
Is it complete now? Do you see the full name?
Yeah.
So chlorine, oxygen, and sulfur are reduced and acts as oxidizing agent. So they are getting reduced, but they act as oxidizing agents because when the sodium is giving out the electrons, it is getting oxidized, but it is a reducing agent. In the other side, the chlorine, oxygen, or the sulfur, they are getting reduced, but they behave as an oxidizing agent by taking the electrons given away by the oxidized sodium, which is a reducing agent. Is it confusing or it is okay?
No, uncle, I understood.
Yeah, so there is a word attached as an agent. Agent means that is something like a catalyst. Do you get that? Which is helping to do that process. So reducing agent means that is getting oxidized. Oxidizing agent means it is getting
reduced.
Yeah. Agent because these accept electrons from the sodium. To summarize, we may mention that oxidation, loss of electrons by any species. Reduction is gain of electrons by any species. Oxidizing agent means acceptor of electrons. Reducing agent means donor of electrons. Is that okay?
Yes, uncle.
So now they are saying that justify that the reaction 2Na plus H2 is given as NaH is a redox change or a redox reaction, right?
Yes, uncle.
Okay, so now there is 2 sodium, and the sodium is a more electron giveaway kind of atom.
Yeah.
So happily, each sodium atom can give 1 electron. So totally 2 are available, and the 2 will go and attach with the hydrogen molecule which has 2 hydrogen one. So it will be like Na will give away 2 Na will give away 2 electron, and that off reaction is called the oxidizing
Oxidation.
and because of that we call that as the reducing agent, and the electron given away by the 2 electrons given away by the 2 sodium atom attached with the H2, that will become a 2H plus 2H minus actually.
Minus.
Yeah, 2H minus, and that
Yeah.
2H minus we call that as a
Oxidizing agent.
Yeah, oxidizing agent, but it got reduced.
Yes.
Okay, that is how we prove that. So we say that is a 2Na plus H minus. That is how we write it.
Yes, sir.
Very healthy. Yeah, okay. I think you're okay with this, right? It's,
yes, yes, sir.
Not getting, so keep, go to the level that it is making more sense and all very clear. Okay.
Yes, sir.
Okay. So anything else?
No, uncle, that's it.
Okay, keep reading, and all the best for tomorrow's exam then. Okay.
Yes, uncle.
Okay.
Thank you.
Okay, we see next week then. Okay.
Yeah, okay. Thank you, uncle.
Bye. Yeah.